All right, if we move on to multiplying and dividing monomials would be something that's by themselves, like a cubed, or there's only one operation involved. So on slide 2, it's going to give us some stuff to fill out here, some fun facts about arachnids. Spiders in North America can range in size from 1 millimeter in length to 7.6 centimeters in length. That's really gross. Use the table to see how other metric measurements of length are related to the millimeter. Now these are nice because there's a nice system for the metric system. Why don't we use that? Anyway, so the centimeter, 1 times 10 is 10, and they call it 10 to the first power. The number 1 by itself, they call it 10 to the 0. So we're moving up here. 0 to 1, 1 to 10. 10 times 10 is 100. So 10 to the first times 10 to the first is 10 to the second. 100 times 10 is 1,000. 2 zeros, 1 0, 3 zeros. 10 to the second times 10 to the first is 10 to the third. 1, 2, 3. 1,000 times 10 is 10,000, which is 10 cubed times 10 to the first, which is 10 to the fourth. 10,000 times 10 is just add another 0, 100,000, which is 10 to the fourth times 10 to the first is 10 to the fifth. 10 to the fifth, or 100,000 times 10 is 1,000,000. 6 zeros, 10 to the sixth. It says, look at the entries in the last column. What do you observe about the exponents of the factors, so like these exponents, and the exponents of the product? So this is a 1 and a 1, and this is a 2. A 2 and a 1 is a 3. A 3 and a 1 is a 4. A 4 and a 1 is a 5. So what do we notice? The factors add to the product, which is kind of cool. Neato mosquito. So and that's what this says, is product of powers. To multiply powers with the same base, remember that's the big number on the bottom, we add their exponents. So we could do 2 to the fourth times 2 to the third is 2 to the fourth plus 3, or 2 to the seventh. Here's a nice algebra way of looking at that. A word for your vocab sheet, monomial. A number, a variable, or a product of a number and one or more variables. So this one, they show us why it works. 3 squared, 3 times 3, 3 to the fourth. And there's all of them multiplied together. There's 6 threes. 2 plus 4 is 6, and there's 6 of them multiplied together. Notice the sum of the original exponents is the exponent of the final product. So we're going to do a little bit of these with expanding them, and then we'll use that shortcut. And then I'm going to let you know if there are coefficients, like in number 3, we're going to multiply them normally so that we don't get worried about what we're supposed to do there. So 5 squared times 5, that's 2 5s times another 5, which is 5 cubed, or 5 to the third. 2 plus, there's a hidden 1 always. Hidden 1. So 5 to the third. This would be 3 c's, or c to the third, times 5 c's, which gives me 8 c's, c to the eighth, and 3 plus 5 is 8. This last one, we're actually going to kind of separate the coefficient, so negative 3 times 4, and then 2 x's, and 5 x's, 2, 5, negative 3 times 4 is negative 12, and 7 x's total, which is the same as 2 plus 5. So remember, there's always a hidden exponent of 1 on each base, so that's why we could add that 1, and that the shortcut, instead of expanding them all, is just to add the exponents. So the way it always works, as long as the base is the same. So if this was a c and this was a d, we couldn't do this, but as long as they're both c's or the same variable, we can. Now quotient of powers is dividing powers, similar but a little different. Shortcut is to subtract their exponents. And I'll show you that here. It says the expanded form. This is why it works. 5 to the 7, there's 7 5s. 5 to the fourth, 4 of them. Well, whatever is on the top and that's in the bottom simplifies to 1. The only thing we're left with is 3 5s, 5 to the third, which is the same as 7 minus 4. So that's kind of cool. So let's practice that over here. We're going to expand the first 2. This one's too messy to expand. We'll just use the shortcut. So 4 8s, or 8 4s. 1, 2, 3, 4, 5, 6, 7, 8 in the top, 2 in the bottom. If you share something in the top and bottom, they would simplify to 1. We're left with 1, 2, 3, 4, 5, 6. 6 4s, so 4 to the 6th. We started with 8. Here was 2. Subtracting, we get 6. This one we have 9 ends. Oh my gosh. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 in the top, 4 in the bottom, 9, 4. If we subtracted those, got rid of the 4 on top that matched the 4 on the bottom, 1, 2, 3, 4, 5. Left with 5. 9 minus 4 is 5. End of the fifth. Now this one, let's just use the shortcut. Shortcut is to subtract the exponents of the same bases. So the base 2, 5 minus 2 is 3. So this would be, 2 to the third times 3 to the fifth minus, or divided by 3 to the fourth would be 5 minus 4, 3 to the first. We could either put the 1 there, or sophisticated mathematicians don't need it. 2, there's 1 here. 2 minus 1 is 1, so it's just 5. There we have it. A few more practice with those ugly ones. We're just going to use the shortcut. So the base of 3 would be 4 minus 2, 3 squared. 2 minus 1, 5. 5 minus 3 is 2, so 7 squared. Base of 5, 6 minus 4 is 2. 4 minus 2 is 2. 3 minus 2 is 1. So you could write it or not write it. Base of negative 2, we have a base of 3, and we have a base of 5. So 5 minus 2 is 3. 4 minus 1 is 3. 7 minus 4 is 3. And there we have it, adding and subtracting when we multiply and divide monomials. No, we got a couple word problems, I guess. So it says Hawaii's total shoreline is about 2 to the 10th miles long, so it's pretty long. New Hampshire shoreline is about 2 to the 7th miles long. About how many times longer? So if I want to figure out how much bigger, how many times larger something is than another thing, I'm actually going to divide Hawaii than New Hampshire. So Hawaii is 2 to the 10th divided by 2 to the 7th. Shortcut says subtract those. So 10 minus 7 is 2 to the 3rd, which is about 8 times longer. A lot more shore. Chase purchased an iPad but had to borrow money from his parents in order to complete the sale. Chase will have to make payments of 2 to the 4th, I think that says, for, let's say that's 2 to the 3rd months to his parents to repay them. What is the total that he'll have to pay? So that's going to be a multiplication problem. So here we divided, so we were subtracting. Here we're changing to multiplying same basis. So we're going to add them. 2 to the 4th times 2 to the 3rd is 2 to the 7th, which 2 to the 7th is 128 months. So that's kind of a while, because if you think about dividing that by 12 months in a year, it's going to take him a little over 10 and a half years. 10 and 2/3 years to pay back his parents. That's a little ridiculous. And there we have it.